What Efenco has made is essentially tiles or a small product which can be fitted into existing system without any extra modification to the process. And essentially what it does is after fitting it, it improves the efficiency of fuel being turned into heat and also reduces the carbon emission that leads to it.
If we go a bit technical, like beyond the magic, we exploit one of the key elements of our technology is pyroelectric crystals, which, in essence, convert heat and other ways of radiation into the electric impulses or electrons.
Hello, Christian. Thanks for joining in Scouted by GreyB. It's very nice to have you. How are you doing today?
Doing fine, and thank you for having me. I'm really doing fine. How about you?
I'm doing good as well. And Christian, like just before I dive in into the complete interview, I wanted to ask: is anything interesting recently happened in Efenco? Anything new that's coming up that not a lot of people know about? Maybe you can tell me in this interview.
That's a good question. You say that you don't want to dive, but to answer that, you have to dive a bit about what we do. Yeah, well, maybe to kind of kickstart conversation, a few words what we do. We actually are in energy conversion business, I would say, and our main target at the moment is energy conversion in combustion, to enhance conversion in combustion, which has been for centuries kind of the same process, but thanks to our, let's say, new perspective, we see that there is much to do, and specifically we have novel ways to create plasma inside normally chemical reaction as a combustion is, and enhance the efficiency of the conversion. And recently, if you ask like that, I would say that we are a deep tech company, and we working in lab with very kind of let's say fundamental level, and we just recently got let's say understanding how to work with our technology. Let's say that if so far it worked 10-15 minutes controlled way, now we have continuous flow of function, if I'm general right now. So it is interesting times for us.
That's great. It's exciting to hear. I'd like to know more about it later. Before I dive in, I wanted to get a holistic view. Maybe if you have to generalize for me, somebody who's outside of this industry, I have no idea of current industry practices, how they work. So can you summarize it in like easy language for me? What is it that Efenco has developed? What does your product look like, and basically what kind of impact you are trying to bring in the market?
Our primary target is actually industrial heat. And let's imagine that there is a factory that produce whatever food, and they have huge gas-based boilers that heat up some kind of process. It's actually one of the largest, 25% of energy is consumed, and of course CO2 is emitted also in that area. It's industrial heat. And let's imagine one boiler where normally there is, let's say, big tube, there is a fire inside, and the energy conversion from the combustion goes to the water, etc., etc. That's our, let's say, situation. And what we do is technology that can be retrofitted, implemented inside the existing boilers. Like it would look like small tiles or whatever the shape is, but those, let's say, passive elements, how we call them, will be installed inside the combustion chamber, and the technology working as follows. The heat of the combustion will initiate the photon generation of inside those our tiles, I would say, which specifically are in soft X-ray radiation range. And this radiation will initiate plasma reactions inside the combustion, which at the end of the day reduces fuel consumption and does the energy conversion more efficient. That's in few words.
What Efenco has made is essentially tiles or a small product which can be fitted into existing system without any extra modification to the process. And
Exactly.
essentially what it does is after fitting it, it improves the efficiency of fuel being turned into heat and also reduces the carbon emission that leads to it.
Exactly.
Okay. So, and it doesn't require any external power source, or it doesn't any modification to the system.
If we go a bit technical, like beyond the magic, we exploit one of the key elements of our technology is pyroelectric crystals, which, in essence, convert heat and other ways of radiation into the electric impulses or electrons. And within those tiles, the technology is called actually vacuum nanotechnology. Inside those tiles, these electric impulses will be converted to the high energy photons, or let's say soft X-ray, in other words. So the inside life of those tiles are quite complex and fundamental physics, but yeah, the function is clear. It will reduce fuel consumption and exhaust gas.
This is a very simple system, but what it is doing is really breakthrough, because it's not adding anything more, or it's not taking more electricity, but the outcome is that it's making a gas based fuel burners chambers more efficient.
Absolutely. Maybe it's worth to mention that um, the kind of breakthrough or innovation, in one hand, is as you said, another perspective, to create plasma is something that industry and science has been known already decades. But the ways the plasma was created was usually demanding external energy, and the application-wise, that kind of limited the application, because if you add energy, you don't gain anything, or the balance is poor. And now the way we found the way to create plasma is kind of entry ticket to the totally different applications that never wasn't available.
Understood. And Christian, again, what I asked initially, that was like a general summary I wanted, but we can go dive deeper into the technology, because our audience is also from various industry. They also have experience in manufacturing processes or in the industrial level production. So we have some people in our list. If it makes it easy, then please go ahead and share all the technical details that you can. So that will also work. Just throwing it out there.
Yeah, I mostly already described the core process, and what might be. Maybe I will kind of rephrase
Yes.
what we do is, in essence, the technology we develop is, we could call it photon generator. It generates photons using this vacuum nanotechnology approach, our patent technology, and actually the core function is to convert waste heat, what is already in the environment, to the meaningful high energy photons. I could kind of dive into the other application areas. What we also foresee, they are, for example, different chemical reaction where the high energy photons can enhance the processes, like electrolysis, also important energy, let's say cornerstone in clean energy topic, or other application areas where we see the function can be exploited, that the waste heat of the process itself can be converted into the next level of reactions. So you kind of internally pump the process more efficient.
I So a lot of industrial system, they have like old or aged custom gas piping, and again very specific combustion chambers. So as your HERC system, it's basically ceramic tiles and they can be retrofitted into existing system. You must have faced some kind of engineering trade-offs to make them this compatible with different type of system for depending on your clients. So did you face any challenge on making them compatible, or was there any engineering trade-off that you had to go through?
The number is unclear how many trade-offs we have to do every moment to develop such technology. In, let's say, in average industrial boiler temperature range, where we work is, let's say, 600 degrees Celsius, but some other applications has maybe 1,000 degrees. So it's a lot of trade-offs we have to do. And to be clear, where we are at the moment, we are still in product or technology development phase. We kind of find and engineers the stability of the solution. We are not into the customers, so the product is not ready as such.
Makes sense. Of course, when you're making something that's so unique and like first of its kind in the market, there are usually a lot of trade-offs. And when I say this uniqueness, I believe, I mean, so far what I understood is there have been plasma based combustion assisting systems in the past, but I think all of them uses external energy, or they
Absolutely.
require they require some kind of modification to the system before they can be fitted, right? So I think that is that the USP, or is there something else as well?
The overall energy balance. If you add to the system energy, you might get something on return, but if the complexity plus the energy balance is negative or very slightly positive, the question mark remains. That's why the plasma combustion hasn't been applied in industrial heating scale, for example. It's very specific. Usually it's applied in jet engines or much more complex, and the tasks for the plasma has been a bit different, but ability to generate plasma using the process waste heat is something totally novel.
Okay. And does HERC affects combustion kinetics for different kind of fuels? For example, like methane versus biogas. Does your client see any detectable shift in flame stability, gas consumption, and these kind of things based on the fuel they are using? Or is it like universally, it works universally with an all kind of gas based or chemical fuels?
To be honest, we I cannot say practically that how it works in other gases or other let's say fuel types, be it gaseous, solid, or liquid fuel. By definition, or we have like our fundamental understanding, which is that flame or combustion as such as a process, the concept should work in any other, let's say, combustion or fuel type. Nevertheless, we know much more about gas, hydrogen, and methane. And application-wise, also, it's much harder to apply it in, let's say, solid fuel combustion zone. It's the dirt and other, let's say, trade-offs or challenges there. For us, it's down the road challenge we don't take right now.
That's great. I think you were right. I think since your technology is working on fundamental, it doesn't really. So what you're saying is basically it doesn't make a lot of difference which kind of fuel is being used, as long as the technology, basically all tech is doing is using residual heat from the system and just increasing the efficiency, which makes
Core
perfect sense.
principle, core principle is the same. Just let's say engineering challenges are totally different.
Understood, understood. And since these are ceramic based tiles, is there any basically ceramic failure modes, or for example, a lot of ceramic based products, they're prone to thermal shocks or micro cracks. Have you observed these kind of challenges in real world testing? And basically what I'm trying to get to is basically, since this is so easy to fit, so easy to retrofit in existing system, what kind of lifetime extension are your customer getting out of the basically of your system, or do they need to change it often after maybe 2 5 years, or is like, that is something I would like to know.
Yeah, well, yeah, again, kind of being aware where we are, haven't been there to say it like out and loud. What is the life expectancy? What we know is that this, let's say, the core element, as I said, is pyroelectric crystals. Based on research, we know that lifetime of one crystal is more than 10 years, or that's the longest period that has been tested. Nevertheless, we internally have been aiming to 3 years lifetime, but we are not there to confirm it.
Understood. And are you again? I've understood the technology very well, and thanks for being with me when I ask you repeated question about the same thing. So basically, I understand the technology, and it sounds very solid and it's very promising. What I also want to understand is basically your manufacturing side of things. Do you see any bottlenecks in manufacturing, or basically what kind of constraints are there in ceramic chip manufacturing that you're basically making?
I have to make one clarification that the ceramic is one, let's say, form factor what we have been tested. As I said, we are in technology development phase, and we actually different materials to see the optimum, or the functional, to kind of enhance functionality and stability. That's why it's too early to say anything about production. Of course, we have some ideas in some form factors quite further developed, but we are not there to say something clear because we are not producing.
Understood. What do you can you share some example of what kind of other materials is your team
No, I
eyeing?
mean, we work with quartz glass as a kind of envelope material, but yeah, there are of course these nanoelectronics are different materials. Question is the envelope material, what we talk about, ceramic or quartz. Yeah, right now those two materials.
And again, what I'm basically trying to get is I want to understand things from a perspective of, let's say, a steel manufacturer trying to partner with Efenco. So what does the process looks like for them from start to finish? What I already know is that your team works as a consultant first, and you review and you help your customers understand where basically your system can bring more value. But can you tell me like how does this process looks like basically, from system audit to final TRC insertion?
Well, no, of course, the question is what are customers' combustion technologies and what temperatures are there is the first. What type of combustion zones they use for what function, that will define initially where the current phase of the technology would be applicable, the giving the temperature ranges. What provide right now. But once more, we are in technology development, so I cannot be further concrete in that customer journey topic.
Understood. And I know basically for what I did the little research that I did, and I went to your website. Again, that my aim is to uncover what currently is not being discussed, and of course, bring more clarity about your solution
And
to the market. I know that you have done some pilot testing, and you were able to see 18% efficiency in the one of the first pilots you might have done. So has there been more testing done, and where you might have seen similar numbers or better numbers, or any kind of impact figures you can share with us?
our journey was that exactly we did this scalability validation pilot in already yeah, more than 2 years ago, where we installed 0.7 megawatt relatively big boiler with our technology and validated the input output, let's say how much gas was used to produce certain amount of heat power, and we saw this 18% difference there. And after that, we went to journey of let's say stability and product development. And so far, we have been developing the technology and find the stability to, as I said initially, that was quite recent, let's say, achievement of our team that we kind of were able to put the technology work more than 24 hours, and we saw that it is sustainable what we expect. So we are approaching again to the validations and pilots and testings right now.
Should understood, makes sense. And I think I have very good picture of what Efenco is doing and how it is working up. What I'm also excited about the future of this technology, because again, I had never heard of plasma being used or PAC type of technology being used like this, which takes no external power and they just use residual heat. Even after the research, we found a lot of system that were used some kind of changes to the system to be installed, or they require some external power. So obviously this is a very promising, and I would say breakthrough even in terms of technology. So what does your future plan looks like? Maybe let's say 2 year 4 or 5 years down the line, let's talk about a sci-fi future where the technology is completely developed and it is commercially viable. What kind of plans does Efenco aiming for? Is it again, I'm going to ask for my personal curiosity. Is it possible that I might have an option to install Efenco's tech in my car's combustion engine and then see a increased efficiency? Is that something like that possible?
It's a good question. Thank you for that. I mean, if we go to the dream world, how we dream, and we dream big, let's say, okay, let's imagine ideal scenario that right now where we work is those, let's say, ceramic tiles or quartz envelope tiles. We have concept and that it can be nanoscale tiles, which allows to enter actually in really different applications, including internal combustion engine. And we have some discussions with jet engines manufacturers that in theory and like obviously everywhere where the combustion happens, plasma would enhance the efficiency of the combustion. So it might be one day. The question is cost benefit for also the end customer application, like small gas boilers is one application area where one moment where the size and price per one unit is makes sense to install it to the let's say end user customers.
Understood, understood. Thanks for taking me through in telling so many details, and I'm happy to see that my imaginative sci-fi future is already on your roadmap. So, which is very exciting. And so, Christian, I don't have a lot of question I left now. Actually, you've answered all of them, but I do have one more curiosity, and that is something like I personally ask a lot of founders, and I wanted to ask you this specifically because this is not the first venture that you're working on. You have been a founder and an entrepreneur for a very long time, and you have lots of experience in this area. And what my question is basically, since this is a like entirely new tech, entirely new industry for you, and in the past I think you have been, whatever you're working on was completely different than what you're doing now. So as a founder, basically, how has your experience been in running different companies? And to be more specific, what I want to ask is, does it happen, and I'm sure it might happen to you a lot, that maybe this is not going to work, maybe this technology might not get adopted or might not reach the scale that we're imagining? So what's your formula to deal with such thoughts, or basically what keeps you going in these cases?
That's a good question. And personally, for myself, I believe at the moment in Efenco, what keeps me going is actually this purpose or mission that I see. If it works, it makes a huge difference. If it doesn't, we tried and we did our best. I mean, there is no question for me in that domain. Is it worth to do it? It's just that's it, basically.
I guess believing in the solution and the impact you're bringing to basically to the world is the formula that you'd like, basically, that you follow, that okay, this is definitely, it's bringing some impact to the industry, and that is what keeps you going. Have I got it right?
Yes, yes, exactly. I mean, we see that they can really make a difference in industry and globally as a humanity in big scale. So it's our job to validate whether we can provide it, and that.
I've talked to so many founders, and I've seen this pattern that drives a lot of different people, and people who are running either their first company or even their like fourth company, but really believing in the solution is what drives them as well. So thank you for sharing this, Christian. And I've had a like amazing conversation with you. I got to know a lot more about Efenco.
Thank you for having me.